ये वाला करें. This is winter 2018. And the question, I said question paper कौन सा? That's let me add people. अच्छा, question paper 2-1. ठीक है, starting with the first question. ठीक है, quickly. So it says give the full electronic configuration of Fe as a full electronic configuration of Fe2 plus. और उसके अंदर just 1 second. अच्छा, Fe2 plus. Fe is 26 electrons. ठीक है, in the periodic table. So that means अच्छा क्या होगा? It means that since it's 26 electrons, that's 1s2, 2s2, 2p6, 3s2, 3p6. ठीक है, remember 4s gets filled first. ठीक है, that's 20 electrons. Up here you've got 26, that's 3d6. And since it's 2 plus, that means it lost 2 electrons. Electrons are always lost from the outermost shell. ठीक है, so that's your electronic configuration for Fe2 plus. अगला पार्ट वो कह रहे calculate the oxidation number of S2 minus. ठीक है, this ion over here, S2 minus. So how do you calculate oxidation numbers? It's S2 and the charge is 2 minus. So S is, you don't know what the oxidation state is. There are two of them, so that's 2x. The total charge is -2. So X will come out to be equal to -1. Okay. So you had S was the unknown, X, और उसको आपने solve किया, and the oxidation number comes out to be -1. Next part, okay, that's an O-levels question, metallic bonding. So make sure you draw a diagram if the space is given, a bunch of positive metal ions. थोड़ा करीब draw करना, bunch of positive metal ions in a sea of. In a sea of free moving electrons. उसको describe कैसा करोगे? It's what is metallic bonding? It's a regular arrangement of positive metal ions. Or it's a lattice of positive metal ions. In a sea of mobile electrons. And what is the metallic bond? It's the attraction, it's the mutual attraction between. So this statement be लिख लेता कि it's the mutual attraction, the attraction that exists between your metal ions and your mobile electrons. ठीक है, that's metallic bonds. Next part is कि iron pyrite is often called fool's gold because of its appearance. Impure samples of iron pyrite often contain a small amount of gold. Okay, so there's a bit of gold in it. The gold can be obtained from impure iron pyrite. The impure iron pyrite is roasted in oxygen to produce iron 3 oxide and sulfur dioxide. Gold does not react with oxygen. The sulfur dioxide produced during roasting would cause environmental consequences if released into the atmosphere. State and explain me karna one of these environmental consequences. So first thing, what does it do? So sulfur, क्या करता है sulfur dioxide? It produces
acid rain.
ठीक है, उसको फिर further explain करो कि what does acid rain do?
So it basically affects the metal structures and line structures. उसको से वो खराब कर देते हैं, corrosion cause करते हैं.
नहीं, थोड़ा सा question read कर लिया करो properly. ठीक है, और जो आप कह रहे हो ना, that's fine. There's nothing wrong with that, but environmental consequences. ठीक है, limestone buildings is not an environmental consequence. What's an environmental consequence?
Absorbs the minerals.
So death of aquatic plants and
soil becomes acidic. That's soil and water bodies, they become acidic. So you get So that needs to be neutralized then. And that would lead to death of plants. Marine life. So remember, read the question carefully. Paper 2 is all about reading the question carefully. The next part is complete the equation to show how the roasting of iron pyrite in oxygen. So he said, okay, it's getting roasted in oxygen. And he mentioned that iron oxide was being produced, which is true, and sulfur dioxide, he stated that earlier. So you just have to, and half the equation is already balanced, so that's easy. So it's how many? 8 sulfurs on the left side, right? You've got 8 sulfurs here, so there's going to be 8 sulfur dioxides. So how many oxygens do you have? That's 6. Or you could say that's 16. 6 plus 16 is 11 O2, right? You get 6 plus 16 will be 22 oxygen. So that's going to be 11 O2. The next part is a sample of iron pyrite was roasted in oxygen. The composition of the mixture of solid products is shown. So you're getting Fe2O3, you're getting AU. Calculate the mass of FeS2 present in the sample of impure iron pyrite. Assume that all the FeS2 was converted into Fe2O3 during the roasting process. So the assumption is that all the FeS2 in the iron pyrite got converted into Fe2O3. So nikalna kya? Calculate the mass of FeS2 present in the sample of as a composition of the mixture, solid products is shown. Calculate the mass of FeS2 present in the sample of iron pyrite. Okay, first thing, we'll find the mass of iron. First thing is we'll find the moles of Fe2O3. So how many moles do we have? इसके जल्दी से find out the moles. Mass divided by the molar mass, which is I think 55.8. ऐसे नीचे दिया हुआ, नीचे लिखा हुआ. Your Fe2O3 is 159.6. So how many moles do we have?
So 0.208.
So we got
0.208.
And then he said that all the assume that all the FeS2 was converted into Fe2O3. So the moles of FeS2 will be double that, right? It's what, 2:4. So how much is that? But double करोगे क्या होगा? That's going to be 0.416.
Yes, 416.
Now he said that calculate the mass of FeS2 present, right? So you can obviously multiply it by the MR. Actually, remember when you're doing paper to show you're working properly. But make sure you know how to. I mean, tell them that this is the first thing that you're doing. TK, write all your working in order. TK, because even if you get your answer incorrect, you'll get marks for your working. There's going to be silly mistakes in your calculations. So make sure. Show your working as clearly as possible. Maybe all the working is perfectly right and you just made some stupid mistake on the calculator. As a mass, even tell them write the formula as well. Like how do you calculate mass? It's moles multiplied by the MR. The moles are given, that's 0.416. And tell them exactly whose mass you're calculating. Tell them that you're calculating the mass of FeS2 multiplied by the MR of FeS2, which is 120. That's given. So kitni aa rahi hai? What's the mass we're getting?
49.8.
Okay, so it's 49.8 grams. And I think that was it. That was the whole question. You just had to calculate the mass of. Don't know why gold was given, but you just had to calculate the mass of FeS2. As the next part is use your answer to calculate the percentage by mass of gold in the sample of iron pyrite. Assume that gold is the only impurity. Okay, so we're assuming So we are assuming that gold is the only impurity. So iron pyrite is basically FeS2 with gold being the only impurity. That's a 1 mark question, just a 1 mark question. We did calculate the mass of FeS2, which is what? 49.8 grams. That's already calculated. Gold is given over here. That's 0.37 grams. So just find the percentage now for gold. Like what percentage is gold out of the total? So 0.37 divided by the total, which is 49.8. Times 100. Okay, answer. What are you getting?
Sir, I'm getting 0.74%.
Yes, we're getting 0.74%. Now, next one. I think that was a simple question. Now, next one. Explain why nitrogen is inert. Give 2 reasons why it's inert.
Sir, it's because they have triple bonds, which is very strong, and they are non-polar.
Okay, so they've got a triple bond. So you're going to write that they've got a high bond energy or large bond energy.
No dipoles.
Or secondly, no dipoles, non-polar. Okay, so they will not be attracting anything. Next is draw a dot and cry. So that's easier. It's a triple bond, right? How many electrons? Nitrogen is in group 5. So how many electrons are left in the outer shell?
2 electrons, sir.
Okay, 2 electrons. Out of 5, 3 are being shared. Let's explain why the reaction of N2 and O2 occurs during lightning strikes and not otherwise, because air has N2 and O2.
Sir, it's because of the high activation energy.
Okay, exactly. You remember, whenever it's a 1 mark question and they ask you, okay, why a reaction requires a lot of energy or why it's not happening, so that's just high activation energy. High activation energy, so large amounts of energy is needed to start a reaction because it's got a triple bond. As the right two equations suggest how the NO formed reacts further to create nitric acid. And 2 equations. I mean, give me 1 equation first. And the first thing, does NO form nitric acid?
No, sir.
Or NO2.
NO2 actually, the first process here, it gets oxidized in air, right? The NO formed, it reacts with air and ends up as NO2. So how does it form nitric acid? What's that equation?
NO2 plus water.
Because you got NO2 plus water and it's going to form nitric acid, but this equation will not be balanced. You can remember you all also have to add a bit of oxygen to it. How many N's do we have right now? We've got 3 oxygens. I have to double this. So that's 4 oxygens, 5. So I need half oxygens over here. Okay, so remember, it's not, you always have to add oxygen over here to form nitric acid. Or there's another equation as well, which is that you can react NO2 with water and it can form two acids. One is nitric acid, the other one is nitrous acid. Both equations are acceptable. So since he was only asked for nitric acid, so I went with this one. Next one. Okay, explain how uncontrolled use of nitrate fertilizers. So he says that nitrate fertilizers are used to provide nitrogen for plant growth. Uncontrolled use of this nitrates cause a reduction in animal and plant life and natural water supplies. What is the process called?
So eutrophication.
ठीक है, तो उसमें क्या, what are the steps? क्या होता है उसमें eutrophication?
So basically bacteria की सर exponential growth हो जाती है algae की, जिसकी वजह से सर वो ऑक्सीजन को ब्लॉक कर देता है।
बैक्टीरिया नहीं बैक्टीरिया नहीं, algae. बैक्टीरिया उसके बाद ग्रो करता है. It's uncontrolled algae growth. Which ends up blocking sunlight, which eventually kills marine plants. And bacteria multiplies because of that, because of dead plants. Why? Because it feeds on dead plants. And because of that, what happens is that oxygen gets used up. And therefore your fish, marine life also, they start to die. As agla part hai ke suggest why, so remember this is all, I mean, this is mostly nitrogen and sulfur, it's O levels inorganic, so why do you add calcium hydroxide to some soils?
So in order to neutralize it?
pH.
Neutralize acidic soils or increase pH or so when calcium hydroxide reacts with compounds containing ammonium ions, a gas is produced. So what is that gas? Calcium hydroxide. Reacting with ammonium ions, what gas is produced? What happens when an ammonium compound reacts with a base?
So ammonia gas is given off.
So this acts as an acid. And this one over here acts as a base. The OH is the one that accepts an H+1, forms water. And the ammonium is the one that loses an H+1, forms ammonia. Or whatever the ions are left, they will form your salt. So the explanation is that ammonium ions are acidic and calcium hydroxide acts as a base and accepts H+1 ions. That's your explanation. Now, another fertilizer, calcium ammonium nitrate, is formed when solid calcium carbonate is added to a mixture of ammonium nitrate and dilute nitric acid. Suggest what would be observed in this reaction. So, it's formed when solid calcium carbonate. So you got solid calcium carbonate. Remember 2 marks, so there's probably 2 observations. Is added to a mixture of aqueous ammonium nitrate plus dilute nitric acid. So what could be observed? What kind of reaction can you have?
Effervescence.
You get carbonate and you've got an acid, right? So there's obviously carbon dioxide gas that's going to be produced, and that's going to produce effervescence. What could be another observation? Another observation for the same thing. Another could be that the solid dissolves because calcium nitrate would be produced and the solid over here is going to dissolve. Color change to koi nahi hoga because they're not transition elements. They don't form colored compounds. So anything that's going to be formed, there's no precipitate also forming. Okay, nitrates are all nitrates are going to be soluble. So I guess pretty much nothing would happen in this case apart from the solid dissolving. I said next one, just 1 second. Calcium
Sir?
nitrate Haji, yes.
So this equation, I'm not finding it in the notes for the inorganic. Sorry. So is it there in the IGCSE?
It's, I mean, this equation, I mean, this one.
Yeah.
It's actually two equations. I don't know what ammonium nitrate is doing over here, but what's the equation of calcium carbonate with an acid? Like when you have a carbonate with nitric acid, what's going to happen? Salt, water, and carbon dioxide gets produced, right? The salt is going to be calcium nitrate.
Yes, sir.
And water and
Ammonia.
no carbon dioxide.
Carbon dioxide?
Because it's a carbonate, right? Carbonate reacting with an acid.
Oh, yeah.
So basically you're going to get calcium nitrate, which is soluble, right? So the solid will dissolve. Plus it also has ammonium nitrate as well. So basically at the end of the day, you're going to get a mixture of calcium nitrate and you're going to have ammonium nitrate as well. So that's why he's saying that calcium, I mean, he's saying over here that calcium ammonium nitrate gets produced. Because it's calcium nitrate plus ammonium nitrate. So it's a mixture of calcium plus ammonium nitrate, right? So what's the equation for the decomposition of calcium nitrate?
So it was CaO with
Metal oxide and
oxygen
moles
and
of
N2.
nitrogen dioxide.
NO2 and O2, right?
Oh, yeah.
What's the color of NO2?
It's brown.
Brown side.
You get brown fumes, and it's toxic as well. I said now, so vapor pressure is no longer in your course. Let's ignore that. I said now you're saying use the data to calculate the enthalpy change of a reaction for the formation of this thing. So if you're given the enthalpy of formation of all the reactants and products, so this is -10, 3.2, this one, HF is, so all of them is given, right? So what is the formula?
So product minus reactant.
Okay, so if enthalpy of formation of everything is given, so it's the enthalpy change of your reaction is going to be the enthalpies of formation of your products minus the enthalpies of formation of your reactants, and you can just do the math now. Take products here, that's CHClF2. TK, remember, be very careful with your calculations. -482.2. That's 1. The other one is 2HCl, so that's plus 2 times -92.3. So minus reactants. So your reactant is, what is your reactant? It's CHCl3, that's -10, plus 2HF. So that's 2 times -273. To kya aa raha hai? What are you getting?
-17.
ठीक है भैया, -17.
Yes, sir. 17.
And the units are kilojoules per mole. Sometimes, very rarely, they might ask you to draw the Hess cycle as well. So just to, I mean, they didn't ask you to draw the Hess cycle, but the Hess cycle for this would be that if formations are given, it's just write down your elements, which are carbon and hydrogen and what else? You got Cl2 and you got, I mean, that's about it. So the elements are forming the reactants, the elements are forming the products as well. That's basically your Hess cycle. So it's these things getting formed from its elements, these things getting formed from their elements as well. And your path, one path is equal to the other path. So what you'll do is, this is the path that you're looking for. So your path, your other path would be this one. Okay, this is path number 1. These are enthalpies of formation of your products. These are your enthalpies of formation of your reactants. TK enthalpies of formation of your reactants are basically the elements forming your reactants, the elements forming your products. So if you follow the arrows, the reactant has to have a negative sign because you're going in the opposite direction. You're going all the way from this side and going to the other side, which is why the reactants have a negative sign over here in the formula as well. Okay, so make sure you sometimes practice your hair cycles as well. But most likely they're not going to ask you, TK, but very rarely they actually do ask. So don't get stuck on that. What's a heterogeneous catalyst?
That is does not the same state.
TK, so reactants and your catalyst don't have the same state of phase. Same state or same phase. Here, what's a catalyst? What is a catalyst? How do you define a catalyst? What does it do?
It's a compound that lowers activation and chemically reacts, but physically it is not reacting.
Okay, first thing, pehle to main cheese, it speeds up the reaction, right? That's the main definition of a catalyst. That's your explanation. Okay, so he says explain fully the meaning of the term catalyst, right? So first thing, the meaning of a catalyst is something that speeds up the reaction, right? How does it do that? It lowers activation energy. Explanation lowers activation energy. So you get more by providing an alternate pathway. Which is why you're going to get more effective collisions. That's the agla part. CHClF2 was used as an alternative to CFCs. CHClF2 should no longer be used because it was found to contribute to enhanced greenhouse effect. So what is the enhanced greenhouse effect? Well, what is the greenhouse effect? The greenhouse effect. What's the greenhouse? Enhanced just means that there's more of it, right? So greenhouse effect is that it's the rise in temperature. So rise in global temperatures as what happens as heat gets trapped into the atmosphere. So that's what the greenhouse effect is. So how would CLF2 contribute to this? What would it do? Why would it cause more global warming? What is that thing that prevents or reflects light in the upper atmosphere?
Ozone.
Ozone. So what chlorofluorocarbons basically do is that in the upper atmosphere, due to UV rays, radicals get produced, specifically Cl radicals. And these Cl radicals will then attack ozone, where they're going to break the ozone molecules into ClO burning and O2. So where they're going to break the ozone into ClO, which is another radical. This ClO radical will then further react with more ozone, form more Cl radicals, more O2 molecules get produced. So the ozone basically overall gets converted into So heat is not reflected back. Why? Because your ozone depletes. So another environmental problem caused by this.
Skin cancer.
Nikechi's another problem associated. I don't even know what the other problem is. Just a second. Quick idea, just a wild guess.
Sorry, the skin cancer.
Second, cancer. Not cancer, by the way. CFCs, are very safe. CFCs are like really good compounds. They're very safe and they're very. They're used in a lot of places mainly because they're very inert. So just a second. So I think it was which part was it? I said traps heat, global warming. It does that. He was actually thinking about it as two different points. Traps heat, honey. That makes sense. Basically, we thought of it as one point. It's actually two different points. Ozone depletion and that is two different points. Because the ability to trap heat is the inherent property of a compound. For example, carbon dioxide traps a lot of heat. So carbon dioxide does that. Bigger molecules generally tend to trap a lot of heat. So that's a different property, and the ability to actually destroy the ozone, that's a different property. So तो यहाँ पे जो explanation थी ना, actually we wrote some of the explanation above. एक से उसने किस तरह आंसर किया है? One second. पहला part C. We give the meaning of the term enhanced greenhouse effect. ये क्या लिखा है इसने? 3B part 1. Just a second. I said enhanced greenhouse effect. अच्छा, this हर चीज एक step नीचे है, ठीक है? Basically, what he's meaning by enhanced greenhouse effect is that it's the human activity, because it's enhanced. There's natural greenhouse effect. The enhanced greenhouse effect is caused by human activity, so that's what he's saying, that there's additional thicker layers of greenhouse gases that is caused by human activity. Second part where he wanted you to explain how it might contribute, that's where we had to write the first. Okay, it would increase the temperature, traps more heat, and it would lead to global warming. So third part, Josana, that was ozone depletion. Is this clear? And remember, in these questions, because this question, especially this question, was kind of vague because you didn't know what went where. So even if you, so the term, you can note down, Mikhailo, when he used the word enhanced greenhouse effect, he was basically talking about human activity that would lead to more of this. So you had to add a bold mark. It's basically human activity that does that. So you have greenhouse effect, carbon dioxide getting naturally being produced by animal respiration. That's a natural process. But then there's enhanced greenhouse effect. So that's caused by additional human activity like burning fossil fuels, your greenhouse gases such as this one. So that is what he meant. So are you clear? Is this clear, this one?
Yes, sir.
Or it's gonna note because italic mein, so basically he wanted you to actually focus on that as well, which we actually did. We didn't actually think a lot about it, how to distribute the marks. I said, but even in that case, if you write something which was supposed to go over here and you wrote it over here, you'll probably still get marks. Most of the time you're going to get marks because the question was very generic. It wasn't very specific. So you would still get marks. Now the next part is, you've got this thing, it's used to produce monomer C2F4. The monomer can be used to produce tetrafluoroethene. What is the type of polymerization of alkenes? Kaun si polymerization of the alkenes?
Addition.
Okay, that's addition. C2F4, right? So that's a double bond and fluorines. And in addition polymerization, they'll just join up. The double bonds between them are going to go away. So thousands of monomers, hundreds of thousands of monomers would simply join up and they'll start linking up. And the double bonds would turn into single bonds. So what's your repeat unit? Because he's looking for a repeat unit, not the whole chain. So your repeat unit is this thing, just this thing. Make sure you draw the continuation bonds at the ends. TK, that shows that, and write an N over here. Suggest why PTFE is used for as a coating for cooking pans.
Because it is unreactive.
ठीक है, unreactive, inert, और क्या हो सकता है? It's one mark, right?
Higher melting point.
So is it that the CF bond is strong, it's heat resistant?
I think that could be another one because CF bond is strong. So that makes it, I mean, that is one of the reasons why it makes it unreactive. So that's like an explanation for being unreactive. So that makes it resistant to heat as well. Normally plastics are not resistant to heat because the CF bond is strong. That's why you can coat cooking utensils with it. Water, even a paper, this is like, most of it is just inorganic. Waste disposal can cause little problems. Stay to other difficulties. So what's the problem with plastics like PTFE?
They are unbiodegradable.
Okay. Non-biodegradable. Okay, which is why what will happen is that landfill sites are needed. And because of that, land gets unusable for hundreds of years. What's the other one? Disposal problems.
So is it burning releases CO2 and other poisonous gases?
Okay, so burning produces CO2, and since it's got fluorine, it could also produce HF, etc. Okay, so harmful poisonous gases. So finally, we've got an organic question. So this is a molecule that's so what is the molecule? It's an alcohol, and it's a carboxylic acid. Okay. So he says, complete the table to show what you would observe when an aqueous solution of glycolic acid is reacted. So basically, what would happen if you reacted with sodium carbonate? What's the observation? Carbonate. Okay, so that's effervescence. Okay, bubbles. Does it obviously reaction occurs? Functional group concept, that's the carboxylic acid functional group, right? So 2,4-DNPH. What does 2,4-DNPH do? Which चार्ट भी निकाल लेते हैं. किसका टेस्ट था 2,4-DNPH?
Carbonyl compounds.
ठीक है, carbonyl compounds was 2,4-DNPH. इस टाइप पे. ठीक है, you always get an orange precipitate with ketones and aldehydes. This is neither a ketone nor an aldehyde, so nothing will happen in this case. Har jagah there's no reaction, nothing. With dichromate 6, K2Cr207. Is this a primary alcohol, a secondary, or a tertiary alcohol? You can't say alcohol.
Primary.
Okay, that's a primary alcohol. What will dichromate 6 do?
Oxidize it.
ठीक है, so क्या color change क्या होगा?
Purple to colorless.
ठीक है, so it's going either तो it's going to be ROH alcohol, not purple to colorless. That's KMNO4. इसका क्या होता है? K2Cr207.
Orange to green, sir.
ठीक है, this one is orange to green. ठीक है. Remember oxidation के अंदर it's KMNO4 is purple to colorless. If you use K2Cr207, that's orange to green. And aldehydes can further be oxidized by toluenes. Toluenes will be silver mirror, Felling will be briquette precipitate. So you can use all of, I mean, you cannot use these two in this case. You can make sure you know the color changes of all of them. Next part. Okay, there's a reaction sequence. Draw the structure of X. So you've got HCHO, which is CHO likha ho na, that means it's an aldehyde, right? So it's a double bond O. And over here, it's turning into this thing. It's turning into CH2. And you've got OH. And you've got a carboxylic acid. Okay, that's your product over here. So what is X then? Kitne reactions are? What do aldehydes undergo? Well, aldehydes don't.
Nucleophilic addition, sir.
Okay, this is nucleophilic addition. This is what happens that in nucleophilic addition, your aldehyde or ketone, HCN gets added. Okay, uska scheme mechanism bhi hai. So nucleophilic addition, HCN gets added to the double bond O, which is polar. So the CN bonds to one side and the other O on the other side attaches to H. So upar OH ban jata hai, niche CN. So that's what's going to happen. So this carbon, I'm going to even draw the mechanism. Like, what's the mechanism for this? It's this is slight positive, this is slight negative. The CN-1 with its lone pairs is going to attack this carbon, and the oxygen double bond electrons are going to be repelled. And phir kya hoga? That's the CN would bond over here. The oxygen will be, the oxygen double bond electrons will accumulate at the top where they'll join with H, and that's how you'll get an alcohol at the top. So it's a cyanohydrin, and a nitrile can be turned into a carboxylic acid. Any nitrile, it could simply be hydrolyzed and it could be turned into a carboxylic acid. So that is what you're going to get. So that's the next part. So this is hydrolysis. So name the reagent for reaction number 2. So that's hydrolysis, dilute acid plus reflux. It's this part, the CN turning into carboxylic acid. Next, he's saying name the mechanism of reaction number 3. Ye kaun sa mechanism? What is this mechanism? Reaction number 3.
So is it free radical substitution?
Okay, this is free radical substitution because remember, carboxylic acid, this is not a carboxylic acid reaction. Nothing is happening to it. Whenever bromine gets attached to the carbon chain, that's free radical substitution. That's bromine, and the reagent will be UV light, and the bromine radicals would go and attack the H atoms and take over their positions. So this is free radical substitution. State the essential conditions for reaction number 3. That's UV light. Wrote that. Then he says, complete the diagram for the mechanism for reaction number 4. Include, now this is a halogenoalkane reacting with, it's a nucleophilic substitution, and he's specifically talking about SN2 mechanism. So what's an SN2 mechanism for a halogenoalkane? That's this one. क्या होता है उसमें directly? Remember, halogenoalkanes have two mechanisms. For SN2, what happens is that the OH minus one directly attacks the carbon, which is positive, goes and bonds with it, and the seal gets knocked out. Okay, so everything happens in one go. So यहाँ पे the carbon is partial positive, the bromine is slight negative. So the OH and its lone pairs are going to attack the carbon, which is positive, and the Br is going to get knocked out. So everything is going to happen in one step. It's a one-step reaction. So I guess that's about it. Okay. They didn't give any space for the transition state, so that's about it. What does NaBH4 do?
Reducing agent.
Okay, the more reducing agent, so it turns NaBH4 basically turns. I say it turns everything back. A carboxylic acid can be turned back into an aldehyde, can be turned back into an alcohol. Well, NaBH4 can only turn back an aldehyde into an alcohol. So that is exactly what's happening over there. कि आपका जो aldehyde है ना, that is turning back into an alcohol. If he had used LiLH4, then the other side would also turn back into an alcohol. But NaBH4 is not a very powerful reducing agent, so it can only do this to aldehydes. Write an equation for this reaction using molecular formula, use the H to represent. So, अब वो formula लिखो बैठ के ना. So what is this? It's CHO and COOH. Reducing agent is H. And the product is what? CH2OH. As a product is CH2OH and COOH. I say balance again. It's how many carbons are balanced, right? Oxygens, you got 2, you got 3 on that side. So remember, so you got 2 oxygens on the left side, you got 3 oxygens on the left side, you got 3 oxygens on that side as well. So the only difference is H's. That's 2 H's. Over there you have 4 H's. So that's, you have to add 2 H's. That's it. TK equation balance ho gaya. Is this clear?
Yes, sir.
Yes, sir.
As the next part, you've got when glycolic acid is heated in the presence, actually, mushkil hai nahi hai. Ek second, how many marks? That's 4 marks. So the question is when glycolic acid, I mean this one, where's the glycolic acid? It's this one. It's a carboxylic acid as well as an alcohol. So it's given over here. So he says that when it's heated in the presence of sulfuric acid, a new compound Y is formed. The equation of the reaction is given. The infrared spectrum of Y is also shown. So you just have to look at the infrared spectrum and check what type of bonds are present. Okay? You can't really guess a lot from this. Okay? There's a lot happening over here. Okay? So below 1500, not really sure. You can't really guess anything. Okay? But you got a strong absorption around this. 1600, 1700. What is the bond that absorbs frequencies at this range?
C double bond O.
Double bond O.
Okay, the C double bond. Let me just open the. So remember, C double bond O has a strong absorption around the 1600. So this is your C double bond. That's your C double bond O. Okay, that's pretty. We're pretty sure about that. Then around the 3000, you've got a sharp absorption around 3000. So if you look at the data booklet, around 3000, you can have an OH, but a carboxylic acid OH is going to have a strong and very broad absorption. This is not happening over there. You don't have a very broad absorption. And then you have an alcohol OH. The alcohol OH have an absorption around the 3200 above 3000, right? So that's also not happening. So which is why it's definitely not an OH. I mean, this thing over here. The carboxylic acid is going to have a strong and broad absorption, right? So it's probably going to have something like this. And the alcohol absorption is going to be above 3000, around 3200. So it's going to be somewhere over here. So not in this range. So it's definitely not OH. So what else is happening around 3000? If you look at the data booklet, 3000 pin, it's the CH bond. Almost everything has a CH bond. Amines are out of the question because you don't have N. So that's out of the question. So every molecule has a CH bond. So this is just a CH bond. So that does not help us because almost every molecule has that. So what we know of right now is, I said we're not getting anything over here, but if you state how the spectrum differs from the infrared spectrum of glycolic acid. So what will glycolic acid have? And what will be different? Now, glycolic acid is firstly, it's going to have an OH. It's going to have two things. It's going to have a carboxylic acid OH. So it's going to have a strong and broad absorption. Around 2500 to, this is what you're going to write. And it's going to have an OH absorption. What data book it's around 3200. The alcohol OH over here, that's 3200 to around 3600. So in these wave numbers, so those are your two differences. It suggests a structure of Y. So you figure out what would be the structure of Y. If you look at the equation, there are two molecules that react together to produce, it's a condensation reaction. So what happens when you have a carboxylic acid and alcohol? What happens when you have a carboxylic acid and an alcohol?
Esters.
It's going to form an ester. So it's probably going to be that the other molecule is also on one side, it's got a carboxylic acid and it's got an alcohol. So the OH and H are going to be lost. The OH and H will be lost over here as well. And together they would, so they're going to form an ester link. And that's why you're going to get two water molecules, one water molecule getting produced over here and the other one getting produced on the other side. And that also confirms our infrared spectrum as well. Okay, you don't really have an OH. Okay, clear?
So the structure looks like that.
How much could improve? Like, let me check the market scheme. They do it like this. He didn't ask for the skeletal formula, right? He just.
That's the structure.
That's the structure. That's the same thing, by the way. It's two carbon atoms. And then you have an ester link. And then isko thoda sa sahi kar lo, okay. Double bond O. Okay, is this clear?
Yes.
बस ठीक है चलो ठीक है ये हो गया पेपर ठीक है कल करते हैं वैसे कोई क्वेश्चन तो नहीं है
सर ये लास्ट का क्या आंसर था
इसका
जी सर
वो था ना कि glycolic acid और इसमें what's the difference is that it's got two OH groups, right? It's got an alcohol OH So glycolic acid over here will have an absorption around the 3200, 3600. This will not, this does not. And it also has a carboxylic acid OH. So it's going to have a strong and broad absorption around the 2500, 3000 mark. ठीक है, clear है?
Yes, sir.
उसका check भी कर लो कि there's carboxylic acid OH and then there's the alcohol OH. We दिया हुआ है. ठीक है? चले, okay then everyone.
So, sir, in
Sir,
tomorrow in the next class, can we also discuss the percentage abundance thing also, sir?
हाँ वो कर लेते हैं, ठीक है?
Okay, sir.
सर क्लास है P2 की.
हाँ वो है 15 minutes में, ठीक है?
ओके ओके.
Okay.